Hello guys. Today we are going to discuss encapsulation principle, right? So encapsulation is one of the fundamental principle of object-oriented programming. Apart from encapsulation principle, then what are the other principles provided by OOPS? The other principles are abstraction, inheritance, and polymorphism. Those principles we are going to discuss in our coming sessions. But today I'm going to discuss this encapsulation OOPS principle. Many students, as well as programmers, especially beginners, freshers, they find it little difficult to understand what exactly this encapsulation principle is. So today I will try my best to explain this concept as simple as possible so that you can understand this concept very easily. So as part of this session, what we are going to discuss? We are going to discuss what exactly the encapsulation principle is, how we can implement the encapsulation principle in CSharp programming language. We'll see different implementation mechanism. We'll see how we can implement encapsulation principle using setter and getter methods. Then we'll see what are the advantages we are getting if we are providing the implementation, or if we are implementing the if we are implementing the encapsulation principle using setter and getter methods, then what are the advantages we are going to get, right? Then we will see if we are not following the encapsulation principle, then what are the problem we will understand. We will also discuss one of the important concept called the data hiding, which we will achieve by using this encapsulation principle. And finally, we will discuss how we can achieve encapsulation in C# programming language using the concept called properties. So all these things we are going to cover in detail in today's session. So let us first understand the definition. According to Microsoft or MSDN, encapsulation hides the internal state and functionality of an object and only allows access through a public set of functions. What it means? You are having many questions related to this statement. What definition Microsoft provide? It it's very difficult or little difficult for us to understand, right? To simplify this definition, what we can say? The process of binding or grouping the state and behavior. Whenever I am saying state means it might be your data member, right? Data member means you, whatever variables, whatever fields you declared in your class is said to be state, and behavior means the functions. The methods what you created inside your class is nothing but behavior. So what is this encapsulation principle? It's all about grouping the state and behavior into a single unit. That single unit might be a class, might be an interface, might be an struct, delegate, anything you can declare as a unit. And if you are following this process means if you are grouping the data member and member function into a single unit in your application, then you are following the encapsulation principle. So encapsulation is all about grouping or binding the data and grouping and binding the data member and member function into a single unit. If you are following the encapsulation principle, then what is the advantages you are getting? The encapsulation principle ensures that the state and behavior of a unit cannot be accessed directly from other units. See, suppose this is one unit. One unit means it's a class. Class is a unit. Inside the class, you declare some data member and you declare some member function, right? If inside your class you declare some data member and member function, means you are implementing the encapsulation principle. Then what is the advantages? Now, if you have another class, right, then that class cannot directly access this data member and member function. Direct accessibility is restricted. You cannot access directly, right? The encapsulation principle is very similar to a capsule. As a capsule bind its medicine within it, in the same way the encapsulation principle binds, or you can say grouped, the state and the behavior. State means the variables, behavior means the methods, into a single unit called class, enum, interface, etc. So you can think of encapsulation as a cover or a layer that protects the related state and behavior. So this is all about encapsulation. So this is the definition of encapsulation. Now let us try to understand this encapsulation principle with some real world examples. So day-to-day life example. As you already discussed, one of the real world example of encapsulation is capsule. As the capsule bind all its medical materials within it. Similarly in encapsulation unit means the class, interface, enum, etc. encloses or binds all its data member and member function together, right? We can also do the same thing in our class interface and our struct. If you take another example of encapsulation, that can be your school bag. If you are a student, then you might be taking your school bag, right? If you are working professional, then you might be an office bag. The bag contains different stuffs like pen, pencil, notepad, etc. within it, right? That means the bag encapsulates. The bag grouped many things inside it. In order to get any stuff, you need to open that bag first or not. Once you open that bag, then you can access the stuff that your bag contains. Similarly, in CSharp, an unit may be a class, consider a class, contain its data and behavior within it, right? And in order to access those means, in order to access the data, I mean the variables and methods, what you need? You need an object of that unit. You cannot access them directly. If you want to access, then you need to create an object. And once you create an object, then using that object, you can access those data members and member functions, right? Now, now let us try to understand this example encapsulation principle with some examples, right? Okay, let me copy this code into my project. Yeah, okay. Now try to observe. This is a class. Yes, this is a class bank, and inside this bank class, I have declared some data member. Data member means these three are nothing but your data member, or you can say these are your data, or you can say these are your state, right? Or you can say these are your variables, and these are nothing but your behavior. Behavior means method means function, right? And you can see this class, right? This class called bank having data members and member functions, and they grouped all these things together into a single unit, and we said that single unit as a class. So by using the class keyword, we are creating one bank, and within that bank, we are grouping data member and member function together, right? Now you cannot access this account number directly, right? From outside world, you cannot access this account number. You cannot access this name. You cannot access this balance variable, right? Direct access is restricted. Then how we can access? If you want to access this data member and if you want to access this member functions from outside the class, right, from outside world, then first of all, you need to create an instance. You need to create an object of this class. And once you create the object, then using that object only, you can access this data member and the member functions, right? And you can see this is a class. This class encapsulates the data member and member functions or not? Yes, these are the data member and these are the member function. So this class encapsulates all these things together into a single unit. Why we are saying it's a single unit? Because within this open and close curly braces, we are writing all these things. So this will wrap all these things together as a single unit, and we are saying the single unit as class bank, right? And this is nothing but your encapsulation principle, right? This is nothing but your encapsulation principle. Encapsulation principle means binding the data member and member function together into a single unit. That is encapsulation, right? Now as I discussed, we cannot access this data member directly, right? You cannot access this data member directly. If you want, then you need to create an instance. See, so suppose I'm writing some method here, right? Console dot write line. Suppose I'm writing some method here. This console is present in a different namespace. You need to bring that namespace. See, I'm writing console dot write line, right? Can I access this data member directly here? You cannot access. This is going to give you some compile time error. Doesn't exist in the current context. This account number doesn't belongs to this class. This account number belongs to a different class altogether, right? And if you want to access the member, or if you want to access the data member or member function, first of all, you need to create an instance of this class. See, here I'm creating the instance of this bank class, right? Once you create the instance of the bank class, then you can access this data member. See, I'm accessing account number, name, right? And you can access this methods like get balance and withdraw money. So this is how the encapsulation principle work. And by default, whenever we are creating any kind of a type, right? It might be an interface, it might be a class, it might be a struct. That means we are following the encapsulation principle, right? But what is the advantages of using encapsulation is data hiding, right? The biggest advantages of encapsulation is data hiding. So what is data hiding? That we need to understand. That means using encapsulation, we can achieve data hiding. So what is exactly data hiding means? Data hiding is nothing but, you can also say, information hiding, and it is a process. What is this process doing? It is a process in which we hide the internal data from outside the world. The internal data is going to be hidden from outside the world, right? From outside, no one can see our internal architecture, right? What data we are storing, how we are storing the data, right? This is going to be hidden from outside the world. Whenever we are saying outside the world means outside the time. Suppose we are creating one unit, right? Inside that unit, you can access the data, but from outside the unit, you cannot access the data directly. This is nothing but we are hiding the data from outside unit, outside the world. Or you can say, if you are creating a class, then within the class we can access the data, but from outside the class we cannot, or we should not access the data directly, right? Then why we are going to hide the data? The purpose of data hiding is to protect the data from misuse by the outside world, right? If we give direct access to the outside world, then the outside class might be misuse my data, no? Suppose you are creating one age variable, right? And if you provide direct access to the outside class, then the outside class can store any value inside that age variable. Na? He might be store some negative values, he might be store some 1000 value, right? Which is not possible, right? So they might be misuse the data. This is the reason why we should hide the data, right? We should hide the data from outside the world. Data hiding is also known as data encapsulation. Why? Now, using encapsulation principle only, we can achieve data hiding. That means without encapsulation principle, we cannot achieve data hiding. So in simple words, we can say that the process of defining a class by hiding its internal data members from outside the class and accessing those internal data members only through publicly exposed methods. Those methods are said to be setter and getter methods or public properties, right? Public properties with proper validation. With proper validation is called data hiding or data encapsulation. What it means? It means inside a class, we are going to declare some data member, but those data members should not be accessible directly to the outside world. From the outside world, if someone create an instance, then he should not access my data member directly. But if he should not access my data member directly, then what is the use of those data members? No use. No. He cannot access the data member directly, but indirectly he can access my data member. How? That will see practically. Then indirectly, if he is accessing my data member, that means we need to provide some mechanism or not? Yes, we need to provide some mechanism so that the outside world or the outside user cannot access my data member directly, but he will access the data member indirectly, and that indirectly mechanism we might be having some setter and getter methods or public properties, right? So if we are using or if we are providing the data member access via the setter and getter methods or public property, then what benefit we will get? Now the benefit is that first of all we are achieving data hiding because our internal data is hidden to the outside world. The advantages is so this is the reason why we can also say that data hiding is equivalent to data encapsulation. Why? By using data encapsulation principle, we can only hide the internal data from the outside world. So you can see the note point. Data encapsulation is also called as data hiding because by using this principle, we can hide the internal data from outside the class. Now the question is, we have understand what is encapsulation or we have understand what is data encapsulation or data hiding. But the most important question is how we can implement this mechanism, right? Already I have told you we have two approaches. One is you can use setter and getter methods, and another approach is by using public properties. So this is the thing, but how we are going to implement the setter and getter method, how we are going to implement this public properties with proper validation, that we need to see. See, if you want to implement data encapsulation or data hiding in your application, then first of all, you need to declare the variable as private. right? Once you declare the variable or data member or field of your class as private, then this will restrict their direct access from outside the class. Once you make anything as private from outside the class, you cannot access them directly, right? Anything means anything. Anything means it might be a variable, it might be a constructor, it might be a method, it might be a property. If you declare them as private, then from outside the class, no one can access it. But for encapsulation, we are using data encapsulation. We basically use to implement data hiding, right? So the variable or whatever variable your class have, they have to be declared as private. Once you declare the variable as private, then this will then from outside the world, nobody can access them directly. But for each variable, right, for each private variable, we need to define one pair of a public setter and getter methods, right? Suppose you are having age variable, then you need to declare a public setter method for the age variable to set the age variable value, and a public getter method for the age variable, which is going to return the age variable. Or you can also use the public properties to access the private variable from outside the class. So we have two options. Either we can go with the traditional setter and getter approach, or we can go with the properties which is provided by .NET framework. Now, we declare the variable as a private. Why? Not to stop accessing them directly from outside the class. The public setter and getter methods or public properties are used to access the private variable from outside the class with proper validation. So once you declare the variable as a private, then then we cannot access them directly from outside the class. Then to access them, what we are going to use? We might be use setter or getter methods, and we might be use public properties, right? Then what is the code we have written inside those public properties or setter and getter method? It's nothing but the validation logic. It's nothing but the logic to set the value into the private variable. It's nothing but the logic to get the value from the private variable. That we will see practically, right? If we provide direct access to the variable of a class, then we cannot validate the data before storing it. Suppose you are creating a variable, right? And if you are creating that variable with a public access specifier, right, then you can directly access that variable from outside the class, right? If you are accessing the variable directly outside the class, then whatever value you want, you can store. There is no restriction to store any illegal data. You can store whatever you want. For example, if you are declaring a variable integer as public, then whatever value you want, you can store. There is no such restriction that the value should be in between 18 or 50. Like nothing is there. Whatever value you want, you can store. So the point that you need to remember is by implementing data encapsulation or data hiding, we are protecting or securing our data, right? So data encapsulation or data hiding can be implemented in CSharp by using the concept called access specifier, right? By using the concept called access specifier. What is an access specifier? Now, an access specifier defines the scope and visibility of the class member. So whenever we are creating a class member, we need to specify the access specifier of that class member. What exactly that access specifier does, it will decide the scope and visibility of the class member. What exactly the scope and visibility means, who can access the member and who cannot access the member, that is going to be decided by the access specifier. And in our previous session, we have already discussed the 6 different types of access specifier that is supported in .NET framework. If you have not watched that video, then I strongly recommended you to watch that video. So what we need to understand, if you declare the variable as private, within the class only you can access it. From outside the class, you cannot access it. Outside the class means from the outside a derived class, non-derived class, same assembly, different assembly, no matter, you cannot access them. But if you make them as public, then you can access it from everywhere, right? So now we are going to discuss how to implement encapsulation principle using our traditional setter and getter method, right? See, this is our example, right? In this case, this is going to be your data member. Data member means I'm making this as a private variable. So as per the data encapsulation principle, whatever variable your class, those variables should be declared as private. So here I'm making this variable as private. And as I make this variable as private, then from outside the class, this program class is outside of the bank class, then you cannot access that variable directly, right? So you can see I'm creating an instance of the bank class, and while trying to access that balance variable, I'm getting one error. Why this error? Because this error is inaccessible. You can see the error, bank.balance is inaccessible due to its protection level. So you cannot access this variable directly. This is the first rule of encapsulation. Whatever variable or whatever data member in present in your class, you need to declare them as private. Then for each variable, for each private variable, you need to create public setter and getter method. So you can see I'm creating one variable get balance, and this variable is nothing but your getter variable. What this variable is going to do? This variable is going to return the data what is stored inside this balance variable. You can see return balance. So if the balance variable contain 100, then it will return 100. If the balance variable contain minus 20, then it will return minus 20. And this method is used to return the data which is stored inside the balance variable. As this method is used for returning purpose, we can say this is a getter method, right? And if you want to write any additional logic, any validation logic, then you can write here, right? And this is going to be your setter method. As the name says setter, it means it is going to be set the value inside the private balance variable. So set the value means this is your balance variable, right? If you want to set some data inside this variable, then you need to call this method. Suppose I'm calling this method by passing the value 100, right? Then what I'm doing, I'm storing that 100 into this class variable balance, right? So you can say when I'm selecting this one, it is selecting this one, right? Selecting this one, highlighting this one means it is also highlighting. That means this dot balance refer to this variable only, right? So if I'm passing 100, you can see I'm selecting 100 means I'm selecting this means this is selected. So if I'm passing 100, that 100 will be stored in this balance variable, and I'm assigning that 100 to this variable means this is the class variable, right? This is how you can implement setter and getter method for the private variable. This is how we can achieve data encapsulation or data hiding by implementing the encapsulation principle. Now from outside the class, right? You cannot access them directly, right? So if you try to access the private things, then you will get error like we have already discussed now. But you can access this method now. These are declared as public. So if you want to set some data, you need to call the set method. And if you want to get some value, right? What is the value stored inside this balance variable? Then you need to call this get balance variable, right? Now you can say bank.set balance. I'm passing 500, right? Then bank.get balance, that 500 will be returned. Now if you run the application, then you will see that it is going to display 500 in the console window. See, the application is still running. Yeah, the application is executed and you can see 500 in the console window. This is how you can implement encapsulation by using setter and getter properties. Then what are the advantages of providing variable access via setter and getter methods, right? If we are providing variable access via setter and getter methods in C#, then we can validate the user given data before storing the value in the variable, right? Suppose you are accessing the variable access via setter and getter method, then what is the biggest advantage is that we can validate the user given data. So whatever data we are setting, whatever data we are sending to store in the balance variable, that we can check, that we can validate. For example, if you do not want to store negative value in the balance variable, you can check and validate the value before storing it in the variable or not. How? See, suppose this is a value, and if you want to check if this balance variable is greater than 0, right, then only store the data, right? If the balance variable is greater than 0, then only store the data. This validation we can implement if we are providing variable access via setter and getter method. That means we can write the validation logic. This is not possible if we are giving direct access to this balance variable. We'll see that problem, right? Right. So the main reason for using data hiding is security. What is mean security? Now see, as we use private access specifier with our variables, we can store critical information in such variable which will be visible only within the class. No one can access them directly. Suppose I'm creating some critical variable here. Critical means private integer, some security number, right? Private integer, some security number, right? So this security number, what is I'm storing in this variable, right? that is not accessible to outside. You can use the security number, right? Whatever the security or any kind of information which is critical, which you don't want to expose, right? You can make them as private. And once you make them as private, that is going to be available only within this class, right? And this is only possible by using encapsulation principle. Right now, what is the problem if you don't follow encapsulation principle? Let us understand this with one real-time example, right? If you do not follow the encapsulation principle while designing the class, then we cannot validate the user data according to our business requirement, as well as it is also very difficult to handle future changes, right? Let us understand this. Suppose you are developing one application for any client, right? The client requirement is that it's come and the client didn't mention anything that I'm creating a class, and in that class I'm having one variable and I can store any value, right? I can store any value, and you develop the class like this. You make it as a public, right? And once you make this as a public, then you can create an instance of the bank class. You can set the positive value. Even you can also set the negative value, because initially there is no such requirement that this variable is going to store positive values or negative values. Initially, it might be possible that we are creating this application to store both positive and negative values, right? So in that case, you can create a bank. You can create the bank class like this, and you can create an instance, and you can access the data member, this amount member directly, right? Now, if you run the application, you can see both 50 and minus is stored inside the variable, and that is what you can see here now. Now, later the requirement changes. Now the client want, hey, this is a amount variable, and I don't want to store any negative value inside this variable, right? Then how you can implement this? This is not possible, right? As you are providing direct access to the user, to the outsider, you cannot depend on the outsider to validate the data before sending the data, right? The outsider means the user can pass anything now. So why should this bank class depend on the program class to validate the data? The validation logic should be written inside this bank class. So the user sending some data, and then before storing the data, I only need to validate the data. I cannot depend on the programmer. I cannot depend on the program class, or this program class is nothing but the outside class. I cannot depend on the outside class that the outside class should validate the data and send me the validated data. This is not possible, right? So what is the important thing? If the outside class is validating the data before sending the data, that is well and fine. But I cannot depend on outsider. I only need to provide the validation. I only need to check the validation logic before storing the value inside the variable. But as the way we have defining our application, we cannot do this, right? We cannot validate this because we are not following the OOPS principle. This is the problem, because we are not following the OOPS principle properly, right? Then how we can validate this? Now to validate this, we need to follow the OOPS principle. Now check this code. Right now, if you look at this, so what I'm doing, I'm making this amount field as private. Private means from outside the class, I cannot access this directly, right? If you check, previously you are passing some minus value, plus value, but now you cannot access this because this is private. Private means this variable only available within this class. See, I'm using this variable within the get method. I'm using that variable within the set accessor or setter method also. Within this class, this amount variable is available. From outside this class, this amount variable is not available. First, you need to make that variable as private. Once you make the variable as private, then you need to return in the get accessor. You just need to return the value, but you need to check the validation logic inside the set accessor. What is your validation logic? What is your business requirement? That you can write here. What is my business requirement? I should not accept any negative values, even 0. So what I'm doing, I'm writing this validation logic. If amount is greater than 0, then only store that value inside the amount variable. If it is not greater than 0, then throw this exception. Please pass a positive value. Now from outside the bank class, so I can create an instance of this class, and then I can access the set amount method and get amount method. Here I'm passing 10. That 10 will be coming to this variable. That 10 will be stored inside this variable. That is fine. But when I'm passing minus 100, then in that case, minus 100 will come to this variable, but at this time, this condition fails. This condition fails means the else part is going to be executed. Else part is going to be executed means it will throw an exception saying please pass a positive value, right? And that exception is going to be handled by this catch block, and that catch block will print that exception message that you are not passing valid data. Please supply some valid data, otherwise I cannot accept the data. You can see like this. So this is how you can implement encapsulation principle using setter and a getter method. Now we will see the same example, how we can implement or how we can achieve using properties, right? The properties are new language feature introduced in CSharp. Properties in CSharp help in protecting a field or a variable of a class by reading and writing the values to it, right? The first approach, that is setter and getter, itself is good, but data encapsulation in CSharp can be accomplished much smoother with properties. Let us see how we can use properties to implement the encapsulation principle in CSharp. Okay, let me copy the code, paste it here. Now you can see this is my bank class. This is my private variable. This variable is only going to store the data. This is nothing but a properties. This property is never going to store any data. They are just a medium of communication. By using these properties, you can have some setter method and getter method. This is nothing but your get accessor. This is nothing but your set accessor. Whenever you want to get the value from this variable, then you need to use the get accessor. And whenever you want to set some value, then this set accessor is going to be executed. As part of the get accessor, I'm not writing any validation logic. If you want, you can write. I'm not interested. I'm not writing, right? So I'm just simply returning whatever the value stored inside this private variable. But inside the set accessor method, you can see I'm checking what is the value you are passing, whether that value is greater than 0 or not. If it is greater than 0, then we are going to store that value. And if it is not greater than 0, then we are just throwing one exception. See, you can see this logic here written. Right? Then what is this value? It is a special variable provided by .NET framework, which is to hold the value what you are assigning to this variable, right? Okay, before that, you just remember you cannot access the private variable, right? If you are trying to access this private variable, then you will get some kind of a compilation error. You can see you are getting compilation error due to its protection level. Inaccessible due to its protection level. You cannot access the private variable directly, but you can access the private variable through the public properties, right? This public, using this public properties, you can access. So here I'm assigning 10 to this public property. So this bank dot amount I'm assigning to 10. So this 10 is nothing but is going to be stored inside this value special variable, and we are checking 10 is less than 0. No, it is not less than 0. So please execute the else part, and once the else part will execute, that value will be stored inside this private variable, right? Now I'm accessing this value bank.amount. So bank.amount means this time the get accessor method is going to return execute. So what is going to return? So what is the value stored inside this variable? Get accessor method is going to return. So in this case, we are storing 10 means we are going to get 10. Now what I'm trying to do is I'm trying to store some negative value, right? And in this case, this minus 150 is going to store in this special variable called value, and in this case minus 150 is less than 0. Yes, condition satisfied. Condition satisfied means this if block is going to be executed. If block is going to be executed means it is going to throw one message, please pass a positive value. It is not going to store minus 150 into this variable, rather it is going to throw an exception saying that you are passing some you are passing some illegal data, you are passing some wrong data, right? So once you run the application, you will see that 10 is going to be stored and you will see the value 10, but when you are passing 150 minus 150, you are getting this message. So this is how we can implement encapsulation principle in C# by using the concept called properties. Now, what are the advantages of using encapsulation? First of all, protecting the data. You can validate the data before storing it in the variable. You can see you can validate the data before storing it in the variable, right? Achieving data, the user will no idea about the inner implementation of the class. So how this amount variable is created, what is the type, right? What is the data type, how he is going to store. The user have no idea because the user doesn't know is there any variable called underscore amount, because that is not showing to the user, right? Even though if you look at the book object, right, book dot, you will see that is bank right? You will see that only amount property is showing, but this is not showing the internal architecture, right? That underscore amount variable, it is not showing to the outside world, right? Security. The encapsulation principle helps to secure our code since it ensures that other unit cannot access the data directly, right? So this is security purpose. Security purpose means you cannot access this amount or this underscore amount directly, right? So you cannot access that amount property, right? You cannot access that amount property or you cannot access that underscore amount. If you want to access, then how you can access? You want to access via this object. You cannot access them directly, right? This is another advantages of encapsulation. Then flexibility. The encapsulation principle makes sure our code is more flexible, which in turn allows the programmer to change and update the code easily, right? Now this is the user of the class. The user of class accessing this variable property, right? Inside this class, whatever logic we can write, we can change the logic, right? Without affecting the user, right? This is the flexibility, this is the enhancement we can do with the encapsulation. The last one is control. The encapsulation principle gives more control over the data stored in the variable, right? It will give more control. More control means now you have the full control. What you want to store inside this variable, you can control it. How you can control it? By validating the data, na? And the validation logic is written in our class. Whatever value we want, we can validate. Suppose we are going to validate, yeah, I'm creating one age variable and I want to store the value if the value is in between 18 and 50. 18 and 60. You can do this. You can do this by using the encapsulation principle. That means we can control the data by validating whether the data is good enough to store in the variable or not. Right? This is all about encapsulation principle. And in the next session, we are going to discuss another concept called abstraction.